Greetings. Um, we're going to continue with our exercise of coming up with a data model, right? And also learning some of the database design concepts. Okay. We started with the domain model. We used UML notation for showing up this domain model, right? And there's basic information, I'm just going to take this picture off. I'm going to delete it. Let me take the picture off. Okay. Now let's come up with so now that we understand what the domain model is, let's come up with a similar picture on um, the database model. Okay. For the database model, um, there's a special kind of diagram called entity relationship diagram. Um, some of Sometimes we actually use the UML itself, and you can do uh, data modeling too with UML, right? But the entity relationship diagram is a little bit more descriptive, and there are tools where if you have a model, you can actually create the table structure in a database, right? So that's where ER model or entity relationship model is very interesting. But for us, in order for us to understand um, the relationships, right? Not to be technically pure, but in order to understand how to build these data models, I thought that entity relationship diagram will be a much bit better way to describe what we wanted, right? So an entity, in database, we have something called as a logical model and a physical model. Okay, actually, there's no difference, even though we think that there is a difference. That for me, it's always I think about, okay, how is it going to be physically represented in the database? Right, that's all I need to know, right? But if you're a database design purist, you will say that, hey, I got to have the logical model first before I can go into physical model. Okay, and what the logical model provides is it provides some kind of inheritance relationship that later gets translated into a composition relationship. Uh, I don't even want to describe what that is. It's basically that if you have some data that you can derive that data and then extend it in two different ways, right? That's logically you can do it, but physically that's not possible in a database. So therefore, you will then say that, okay, even though you're extending it, you kind of repeating the data in different places, right? I'll show you. If I show you an example, you'll get a better idea. Okay. So let's look at one of the things that we thought about. It's like the order, right? Let's look at the order first. Now let's look at when you are building this order, right? Um, you can do something like this. Okay, I'm just going to delete all these. So there's key and field, right? Um, I'm just going to remove the keys. Okay. Okay, and I'm going to put the fields first to start with, right? Now I know that by default, this guy will try to give you a primary key, right? Just ignore the primary key for now. So your order as an order number, right? I'm still going to use the camel case structure, okay? So you have the order number, um, order date, then order date. I'm trying to think what all you can put in the order, okay? Then I will put shipping address. Okay, let's see if I can add more. Insert row below. Okay. Order status. Okay, and then let me add one more field. Order status date. Okay. Okay, and I'm not going to have the keys right now. Okay. Now, this is a table which has order number, order date, shipping address, status, and status date. Okay. Now, just think about it. If you take the shipping address, the address will have, at least in the US, right? You'll have a street address. Um you'll have a street address like 1234, something road, right? And you'll have a city, state, and zip code. Okay. Now, the thing is that if we are very lazy, okay, what I can do is that I can just say that, hey, I'm just going to put a comma separated shipping address. Okay. I can put something like 9245 Roger Street, and something like Columbus, Ohio 77456 as the address. Okay, and it's comma separated. Now, when you do that in a table, then your table is terribly wrong. It's not normalized. Okay, why is it not normalized? Because that address information that you put for shipping, let's say that tomorrow you want to do some kind of drone technology you're going to introduce, and you want to take the zip code from that address, and then you want to take the address and then map it to some geolocation software, find the latitude and longitude, and actually deliver this thing there, right? Now, what you will have to do is, in that case, you will have to extract the address, then use some kind of application code to parse the content of that address, and then pass it on to the geolocating software. Okay, so when you do data items, when you have multiple data items in one field, then your data is not normalized in the first normal form. Okay, in the first normal form, what happens is each data element should be in one column and one row. In here, shipping address is multiple columns embedded in one cell. So that means it's not normalized. Okay, that's the first issue. The second issue is that now I wantedly, so I have order number, order date, shipping address, order status, and order status date. Right. Now, what is the type of this order of these fields? Okay, one in the very first project which I was involved. So I had a lead engineer who sat and said that, hey, why do we need to make these types, like this is an integer and this is a boolean and this? Let's make everything as a string, right? Things will get much easier, right? You make all the fields a string. Will it be easy? Well, again, wrong. Why? Because if your order number is going to be a number, an integer, if you say the type is string, then people can type anything, right? And then what will happen is at the database level, you're not catching errors. The idea is that even if application has, like, programmers make a bug and somebody enters wrong information, that the database should be catching these kind of data integrity errors so that your database, when it grows really big, you don't have huge costs in fixing that, right? So having a type that is very, very specific to that column also means that's the first normalization step that you need to take. Okay, so that is why if you take another entity, this is an entity, right? So this one has, is that a key? Is that a field? Is that a type, right? So I'm just going to go ahead and I'm going to do order. I'm going to change it now. So this is the first normal form. That is, I'm going to, the database, the table was not normalized in the very beginning. Now I'm normalizing it to the first normal form. Okay, how do I do it? So I still have the order. I'll put my order number. And we make it bigger. And I'm going to call that as a number. Okay. I mean, the type that you put doesn't have to be exactly matching your database system, because I know that some systems have this field type called number, some call it as integer, some have, even in integer there are different types, big integer, small integer, etc. So I don't want to get into that debate, right? But all I'm trying to say is, I'm just saying that um, that I can put some type that logically makes sense. Okay, so the order number is a number. The order date is a date. Okay, now watch this. The shipping address, I need to write this as street address or street number or home number. Okay, and I make that as sometimes those numbers are alphanumeric. So I'm just going to make that one as a string, date and string. Okay. Now I know it can be varchar or something, right? I'm just going to call it string. Okay. Then I'm going to add row below. Let me add more rows. Row below. Row below. Row below. Row below. Okay. So home numbers, street, address. Home number is like, let me talk it, make it as apartment number. This is optional because sometimes your apartment number may not be there. There may not be apartment numbers, right? But there's the street address. Then I have city. Then I have state code and zip code. That's a string. That's a string. State code is a string. Zip code is a number. Oh, I know, like the Canadian postal code has characters in it. Doesn't matter. Right now, it doesn't have to be pure. We just put something here. Then I have the order status. And let me add one more row. Order status date. That is when that state, when happened with that states. Again, I'm not going to talk about keys right now. Okay. So I have order number, order date, apartment number, street address, city, state code, zip code, order status, and order date. Okay. Now, just to make life little bit easier, I'm also going to add one more column before the apartment number column, so row above, and I'm going to put um, addressee name. Okay, addressee name. Okay, so the name in the address. Okay, so I'm going to put that in there. And then the last field, order status, is already there. So I'm just going to delete that. Okay. So I have order number, order date, address name, addressee name, apartment number, and addressee name. I'm just going to put that as a string, and order status date. I'm going to put that as a date. Okay. Now this table, as it's now a first normal form. Okay, so that means that I'm going to delete this off. So I went to the first step, which is first normal form, where what I did is that I assigned a data type to every field, and I made sure that there is no compound data types. In other words, that I don't put the addressee name, apartment number, street address, city, state code, zip code, everything into one specific field, right? I'm not jumbling things up. Now my data has become a little bit more easier to look at. Okay. Now, one of the things that you will have to do is, once you have your data like this, you need to do something called as, hey, what is the key to this data? Okay, what's the key to this one row in my table? What is the key? Okay, finding the key is a very interesting idea, and another bad habit, bad practice everybody has, is that without understanding what's the key, they just come up with what is called as a surrogate key. Okay, what is a surrogate key? Surrogate key is like a serial number or a generated number or a UUID you just put so that your row is unique. It can have all kinds of duplicates, but the row becomes unique because you put a surrogate key, right? Very, very bad practice, right? First, look for keys. Now, those keys are called as candidate keys. Okay, these are candidate keys, possible candidate keys. Okay, and then I know that there are some natural candidate keys. First of all, are they right candidate keys? You got to do some analysis. But after you found the candidate key, some natural keys are a little bit inefficient when you want to, index it or something. And then the other thing with some of the natural keys is that sometimes the natural keys can have duplicate, right? That could be, so for example, sometimes we avoid making names as keys. Okay, email addresses are okay because they are always going to be unique, right? First name, last name. Sometimes what will happen is it's a different person, but they have the same first name and last name. In some cases, you may have to come up with a surrogate key. Okay, but in most cases, you should have a natural key. Okay, and in some cases, and we'll talk about that. In some cases, what will happen is that you will have a related key. Okay, um, okay, and in some cases, you can also have. So it's not one key; there is a composite key, right? That's also possible. So you got to look at those things. Okay. Now, if you look at this thing, this order, First of all, order items are not even there. Okay, in theory, you can also put the order items in the same table, right? But I'm looking at the candidate key. I definitely think order number in any business, order number is always unique, right? One, it's unique, and I think it describes. So if I want to get the order, all I need to know is an order number. Okay, so order number looks good. What about addressee name? That this order is for an addressee, right? For somebody whom you're shipping. Can that be a candidate key? Well, if you're searching for what's the address, what's the orders for this addressee name, you probably need to get all the addresses. Maybe that's a candidate key. I don't know, right? What about zip code? Can zip code be a candidate key? What about order date? So these are questions you need to ask. But this one is a very simple table, and I can easily see that order number is the key, is the candidate key. And now once it's a candidate key, now I look at it, it's a number, it's an order number, it's unique. So therefore, that can definitely be my primary key. Okay. So if I have, let's say I call that and primary key, you denote that by saying it's a PK. PK means primary key. Okay. So that one is my primary key. I kind of said that, hey, that's the order number is my primary key. Now what you do is that in the second normal form, you're going to the next step of normalizing the table. Okay, and again, I want to repeat, normalizing means structuring your data in a way that you avoid duplicates, and it's easy for you to add, remove, and modify your data, right? So the way you think about the second normal form is, first of all, second normal form has to apply the first normal form, the rules of the first normal form. And then you need to look at the best way to look at it. And people tell that, hey, you need to remove all partial dependencies. Okay, what does that mean? It means very simple. The data that you have in this table, do they get directly related to the primary key, and is it directly related to that, right? So for example, your order number and your order date and your order status date, I need to add one more, and your order status, let me add one field more. Okay, those all seem to be having a straight relationship to the order. Whereas the addressee name, the apartment number, the street address, city and state code and zip code, those seem to have relationship with your customer, and it also has a relationship with the order. It's a customer's shipping address, right? So those are partial dependencies. Okay, so if there are partial dependencies, what you do is, instead of keeping them in one table, you divide that into two tables. Okay, because think about it, that you have one order that you've shipped today. You sent one order, okay, for the same for that address. Tomorrow you send that to another order for the same address. For the whole year, 1,000 times you're sending order to the same address. You see that those address fields will keep repeating for no reason, right? So that's why that is really bad. Okay. So let's say that, so now that we have the order, it looks like the shipping address need to go into its own entity, right? And I'm going to pull another, well, let me not do that. Let me do this. This is easier. I'm going to make a copy of it. And I'm going to call this a shipping address. Okay, and I'm going to delete that field. It doesn't have an order number, so I'm going to delete things. Okay. And I'm going to delete that row and delete that row. Okay. Now coming back to this table, I'm going to take the addressee name. I'm going to keep the addressee name, and I'll tell you why. I'm going to delete all that thing off. Okay. Now what I'm going to do is that in the shipping address, again, don't think in purity terms. I'm just saying that, hey, the key here definitely seems to be the addressee name. Okay, there's going to be one person in that house. That's the name, and therefore that should be my primary key. Okay, just bear with me. And so I have an order, and I have a one-to-one relationship with the shipping address, at least for the order, right? Because you're not shipping, the order is not shipped to multiple addresses. You're shipping it to only one address. And I'm thinking that the addressee name is a foreign key. Okay. So if I need to get the order address using this foreign key, I can say, oh, okay, for that foreign key, I have a shipping address, which is the primary key. So a foreign key is a primary key of some other table. That's called as a foreign key. Okay. So if I want to get the order address, I can just go to the addressee name, search on the addressee name, then I'll get the shipping address. Okay. So what I've done is that I've taken the partial dependency and created my own table. Okay. And then now there is a relationship between these two tables, and that relationship can be modeled as so. Here's a relationship. And generally in ER diagram, you see there is a there is an horizontal little line in there at the side. That means that's a 1. This side there is a triangle with 1. That means that's a many. Okay, but the relationship is not 1 to many. The relationship is actually 1 to 1. So in that case, what you can do is you can click on that and go down here, and there will be a 1-to-1 relationship, right? So you put that there. So that denotes that that's a 1-to-1. So you actually put a cross line there, and that's a 1-to-1 relationship. Okay, very good. So I've normalized the table. These two tables are now in the second normal form of normalization. Okay. So when I look at this normalized table, the next thing I got to think about is that first is that there is this problem in this structure. Okay. Because an house can have 4 or 5 people, and so there may be multiple addressees in a house. So therefore, putting the addressee name in the shipping address will not work. Okay, number 1. Number 2 is that what if it's just a PO box, right? So it's not a street address, it's just a PO box. Now I could probably make the street address as a PO box with city, state, and zip code. In that case, you don't need to have an addressee name, right? So the addressee name being the primary key is problematic. Okay, that's number 1. And the other thing is that, well, you really need to know about the customer, because it's the customer's address, and the customer may have multiple addresses, multiple shipping addresses, okay, associated with one customer. So how do you deal with all these things, right? Those are things that you need to talk about. But then there's also this other thing that is called as that you also can normalize the tables further, and that is called as a third normal form. Okay, so usually in the corporate world, in the business world, you go up till the third normal form normalization and you let it go. There's a next normal form called Boy's Code normal form. There's a little bit stricter rules than um, the third normal form, right? And the other thing about Boy's Code normal form is that a lot of people are not going to go that strict. Sometimes you may use Boy's Code normal form. And then there's a fifth normal form and a sixth normal form that is defined in the academic world, right? In fact, I'm not even going to address that because in practical terms, once you've done your third normal form, you should be kind of okay, right? And again, the other thing that you need to practically think about is you're building a UI. There's going to be some requirements on how long this application is. Is it throwaway code? Is it going to be there for 1 year only? Is your retrieval very efficient? Or there's some algorithms you're applying? All that thing matter because you may sometimes, instead of normalizing a table, you may denormalize it for certain situation, right? So don't think that a normalization is like a scientific formula that I need to apply for every table. That's not true, right? What you need to do is you need to reduce the complexity and the duplication and the redundancy of data, because here you can have multiple. So you can have the one shipping address that can be associated with multiple orders, right? And that's the next thing that we're going to come to. Okay, it's not a one-to-one relationship; it's a one-to-many relationship. But that's not how we'll deal with that. I will tell you how we'll deal with that issue. Okay, but the third normal form. So the second normal form says you should not have any partial dependency. The third normal form says that there should not be any transitive dependency. Okay, what does transitive dependency mean? So I know that the addressee name is associated with this apartment number, street address, city, state code, and zip code, right? Now, what if there is a state code and the state name? Now, that is transitive dependency. That means that they are, of course, related to address. They are related to the primary key. They are related to the addressee name. But what really happens is that they are transitive dependency, which means that they can still live on their own. Like state code and state name can live on their own, right? So for that, you may have to create its own table, right? So that is something that you can do, okay? Or you can put the street address. If street address is unique, then you can put the street address and city, state, state code, and zip code in its own table. That's the third normal form. Okay, so you should eliminate all transitive dependencies. That means that it's still related, but still it looks like there's a candidate key that can come, and then that can go into a different table, right? But right now there is a problem with our domain model itself. Address as shipping address, but order is for a customer, right? So what I'm going to do is I'm going to make another table for customers. Okay, I'm going to call this customer, right? And for a customer, I'm going to jump all this normalization and everything, and I'm going to put something here. So a customer the primary key of a customer. What is the primary key of a customer, right? One, you can use email address as the primary key of the customer, right? Many websites use that. They're comfortable with it, and then if you use the same email address, they'll say that, hey, this email address is already taken. You already have an account, right? So for example, for a website like Amazon, for most of the online websites, you can have one email address associated to that account. Nothing wrong with it at all. But where things go wrong is that one, people may like to change their email address sometimes, right? So there is a dummy email address or an email address that you lost control of. It's been hacked, or you forgot about it, right? Many times we create all these free email addresses and then we forget about it. So now I want to change my primary email address. And usually changing the primary key is really frowned upon, because once you go and change the primary key, you got to go and change the primary key for many, many, many rows, right? And so it's literally you got to delete the table, add the primary key because the indexing and everything has to be done again, and then you need to create a new table. So generally what you do is you avoid putting things like email address, which will change over time. First name, last name, sometimes will change. If you get married, if a lady gets married, then she may like to change her name. Even sometimes I've seen that men also, when they get married, they change the names, right? When the names change, or legally the names change, there will be a problem, right? So that is why that things like customer, you can assign a surrogate key. You can generate and assign a surrogate key, because things like email addresses and first names and last names may change over time and may cause problems, okay? And having a surrogate key is really a good thing. For example, in my company, every customer has something called as a member ID, right? It's uniquely assigned to them. In banks, many times you have an account number, right? So it represents you. It's a number that's generated uniquely for you, and it's assigned to you. So it seems like a natural key, but it is a surrogate key, right? Um, so I'm going to put a surrogate key here, customer ID, okay, and that's a number right now, okay. And then customers generally have a first name and a last name and email address. Okay, first name, last name, and email address is string. Okay, now I'm going to use one more thing like verified. Okay, and I'm going to call that as a boolean. This is customer verified? And that, remember that there is some situations where the customer has registered but is not verified until they get verified, right? And in many cases you're sending SMS text to the customer. So I'm also going to add, let me go back, insert row above, and I'm going to put phone number. Okay, these are things that talks about the customer. Now customer contact information is different. This is for the customer, what is the primary phone number, right? So I put first name, last name, email address, phone number, whether the customer is verified or not, right? Um, and then we can also talk about let me see. After verified, I'm just going to insert a row below and say created date. Okay, when was this customer actually created? Okay, and date. Okay, so I got the customer in here, and I wantedly, I mean, in the good, or if I didn't normalize, I could have had the customer address in here, right? Then we come to the realization that the customer may have multiple addresses, number one, and the customer can also have multiple shipping addresses, right? Those are all possibilities. So instead of associating the shipping address with the order, it's better to associate the shipping address with for the customer, right? And remember that, see, I can order for example, I want to send a gift. So I can order something for my friend. So my friend's name will be different. And for the friend, I will have an address. So therefore, the addressee name will be different. But the addressee name is not necessarily my name, my first name and last name. You see that? So now what I need to do is that I need to fix the shipping address primary key problem. It cannot be the addressee name, right? It has to be something else. It's possible that I can use I definitely this shipping address is for the customer, but it could be one of the addresses for the customer, right? So in that case, what do you do? Okay, I'm just going to insert a row above. I'm going to have the customer ID in here, which is a number. And in this case, that will be a primary key and a foreign key, correct? Because it's a key of some other table. Okay. But that's not enough, because a customer can have multiple shipping addresses, right? So this is the place where you can put another primary key, composite key, it's called as, where you have two keys for one table, right? And here you put something like a shipping sequence number. And that's also a number. Okay. So you got the primary key and the foreign key. So you're saying that, A, for every customer, there are multiple shipping addresses. The primary key for it is customer ID, but there is a sequence number, okay? And still you will have, let me see, let me put another field. Let me after the shipping sequence number, you insert a row above and put, it's not a key, but it's the addressee. And again, I'm going to say first name, because remember that addressee name means first and last name together. You're violating the first normal form rule, right? So I'm just going to put first name as string, and insert a row below, and the last name as a string. Okay, and I'm going to take that as that's not the key. Okay, so now I know that as a customer, I have my own first name, last name, I have my email address, I have my phone number, but in the shipping address also I have customer ID, shipping sequence number. So that means that for that customer there will be multiple shipping sequence numbers, and that makes that row unique. And the first name, last name, apartment number, street address, cities, state code, and so we never name the state. We always use state code. I'm very biased with the US address, but that's okay. I'm not going to make it too complicated for the sake of the class. So now I am going to relate this, and it is in fact a one-to-many relationship, right? So I am going to say that, hey, there's a customer, and it's going to be a one-to-many shipping address relationship, right? Now the question is, okay, so I have the shipping address and I have the customer ID. Now you do need to know in the order, you need two things. You need to know to which customer is this order being made, correct? And then to which shipping address is this order being shipped, okay? So you see, in order to get that information, you need the customer ID and the shipping sequence number, correct? So instead of having the addressee name here, I'm just going to put the customer ID as one of the foreign keys, right? And then you also need another foreign key, which is basically shipping I should not call this as shipping address sequence number. I mean shipping sequence number, because that tells me the sequence of shipping. It's actually the shipping address. I'm just going to put ADDR, shipping address sequence number, right? Shipping address sequence number. Okay, and that is a number 2. And that is a foreign key. Okay, so given those 2 foreign keys, you have now the ability from the order, you can go down to the customer as well as you can go to the shipping address. Now, the relationship between the order and the shipping address is every order will have only one shipping address. So that seems to be right? If I take the customer ID and the shipping address sequence number, and that is the customer ID and the shipping address sequence number that shipping address is going to be related to, right? So that's the shipping address. Now, the order is also related to that customer, right? So there is a there is actually one-to-many relationship between order and the customer, right? So if I take an order, I need to do it in the opposite direction. There is going to be so one customer can potentially have many orders, right? But you cannot have two customers. We cannot have 2 customers for one order. Only one customer can do an order, right? So it's going to be one customer who is going to have multiple orders. Okay. So I think you're getting an idea of how this data model is being done, right? It took some time for me to explain these things, but you're getting an idea. Now I'm going to come up with a new problem, okay? And this happens in the business all the time. So therefore, I never get this thing that, okay, I'll get my data model the first time right. Probably not. And then the other thing is that don't also be caught up with, oh, I got to spend a lot of time understanding the data model, right? That's a waterfall method of building applications. That'll never work, okay? Sometimes what you need to do is you need to be flexible enough to change the data a little bit here and there until the system becomes a little stable, okay? So I'm going to introduce one idea. So this model looks nice, but there's a problem in this model. I'll tell you what that problem is, okay? Because a customer comes in, the customer registers himself or herself, okay? So they put we assign a customer ID. There's a first name, last name, email address, phone number, whether the customer is verified or not, and create a date. Now, it's quite possible that I want to still keep the email address as a unique key, right? I still want it to be unique, okay? But it's not the primary key, right? So I can just put a UQ so that I can create a unique index for that email address, but it's still not the primary key, okay? With that, there's no way that somebody may change will have a different email address. But if somebody wants to change an email address, I'll still allow it as long as it's unique, right? If the email address is already taken, I'll tell that email address is already taken. So that is safe, okay? Now, for the order is referencing a shipping address that is maintained for the customer, right? So the customer always maintains a shipping address, and that's related to the customer ID and the shipping address sequence number, okay? Okay, good. Nice, right? But here's your problem. What if the customer goes and looks at one of the shipping addresses? And so let's say that my friend, his name is, I don't know, um, uh, Roger Stone, okay? Some name I'm coming up with. So my friend has moved from a house to another house. So I'm just going, and so like next week he has moved, or last week he has moved. So I'm just going and changing the shipping address and saying that, okay, in the future, if I need to send you a gift, I need to know your address, so I've changed the address. Okay. And then now you are, let's say that after a year, you're going and looking at your order history, and there's your order. But when you want to look at, hey, where it got shipped, it will show as though it got shipped to the new friend's address, but which in fact was shipped to a old friend's address. You see, there's a problem, right? So the shipping addresses that you store for the customer might change over time. Okay, so for an order, even though you are kind of pulling the shipping address that's saved for a customer, but once the order is created, the shipping address has a possibility of change. Okay, so what do we do now? Right? Will be Amazon face the same problem? Okay, how can we solve the problem? It sounds like you need to record the shipping address of the order at the time when the order was taken. It's okay for the customer to have an address book kind of app where they will keep the different addresses uh, that they will ship to in future potentially, and we will very freely let them change that address whenever they want. But um, when I'm actually making an order, the shipping address has to be different. Okay. So now what happens is, how do I manage this? How do I manage an order to have its own shipping address? Okay, very simple. So this is the address book shipping address, right? That is good. Let's keep it there. This is where sometimes your idea of, hey, I'm eliminating all duplicates won't work, right? You are bound to have some duplicates. So the shipping address is there. Okay. Let's take that off. Okay. So the shipping address is still there. And you have the way you can solution this is, the way you can have a solution here is, man, I'm just going to take that relationship and build that again. So one possibility that you can do is that, hey, I'll let the customer have um, a shipping address, right? And then for the order, I'll have another copy of the shipping address and call it as order shipping address. So I'm duplicating this whole shipping address there again, and I'm saying that, hey, that's the order shipping address. And will that work? Yeah, probably it will work, right? But is that the right solution? The truth is, that's where the Boyce code normal form and the fifth normal form and sixth normal form comes into play. See, your apartment number, street address, city, state code, and zip code is unique. As long as that apartment is there, until there's no fire, that address is unique. And the postal department will make sure that if there is a fire, everything is broken down, and if there is new address popping up, then they will assign different numbers, right? So the apartment number, address, street address, city, state code is very unique. But apart from that, the latitude and the longitude of that address is always going to be unique. Given that today we are using all the mapping application stuff, that we know that the latitude and longitude, or the uh, location, latitude, and longitude of an apartment, of a house, is going to be the same. Okay, so that's one problem. But then what if the apartment is multi-story? The latitude and longitude will be the same, but there may be multiple apartments in that latitude and longitude. So for mapping application, maybe that will work, but for a shipping application, that may not work, right? So it's possible that you have another table, something like this. Okay, I'm going to show you the table now. Let me pull it this way, and I'm going to come up with the table. Okay, so let me take a smaller table, copy it. So I'm going to put a location code, okay, which has the apartment number or suite number, it doesn't matter, okay, and the latitude and the longitude. Okay, and I'm not having order status and stuff. So there's a location code which has the apartment number, and apartment numbers can be a string, so I'm going to put them string. Okay, and so and a location code is a surrogate key. These are not keys anymore; those are latitudes and longitudes. But that is kept as a record. Okay, so I'm just going to put called as a location. Okay, it's called as a location. Now, even for the location, I'm going to take the I need to make the location code to be the primary key for this kind of thing, where you can have the same latitude and longitude repeated, okay, but the apartment number is different, right? Same latitude, longitude, apartment number is different, and that one has a location code. Okay, so and I call this table as location. Okay. Now, instead of shipping address, I will have another table. Okay, which has the location code, right? The apartment number. Well, let me not use that table. So then let me take this off. Let me take the shipping address. Okay, here I am going to have the location code. Okay, I don't need the apartment number. Okay, location code is a primary key and a foreign key, right? I don't need the shipping address sequence number, so I'm deleting that. I'm deleting the first name and last name. And I'm also deleting the apartment number. But then for that location code, I'm just going to put the street address, city, state code, and zip code. Okay. and I'm putting that as another table, okay, and I'm going to call this as location address. Okay, so for a given location code, there is going to be a location address, right? Now you may understand that between these two tables, the street address, the city, state, and zip code is going to be the same, but the apartment number is going to differ. All right. And therefore, if you see that there is still a normalization issue here, because it sounds to me that the latitude and longitude has to belong to that location code, right? And obviously, the apartment number is going to differ, where it's the so it's different location codes because the apartment number is different, but the latitude and longitude and the street address and the city and the state and the zip code is the same, right? So if that is the situation, then I think the primary key here will not be actually location code. It will be the latitude, which is a number, and I'm going to add one more field, and the longitude. So both are primary keys here to this location address table, right? Then for that location address, there could be a location code with just the apartment number, because for that latitude and longitude, there could be a location code because there is an apartment number. Okay, so I have a location code that says that is a apartment, right? Now here's your problem. Sometimes you don't have an apartment. there's only one apartment, right? Or there's only it's your street number. So you have a street address, right? And there is a home numbers, right? So for example, my house is in Putnam Drive, but I have a home number, right? 1, 2, 3, 4, whatever. So what has happened here is that, so sometimes you'll have an apartment number, and then you'll have a street name. So I'm going to change that to a street name, correct? So there is a street name, then there is a street number, right? So there's a street name and a street number. And then sometimes you may have an apartment number, sometimes you may not have an apartment number, right? So let's put street name, and just to make sure things are okay, we are also going to put a building, could be a house number, right? And that can also be, so this is a number, this can be a string, sorry. So there's a building number, there's a street name, there's a city, and zip code, okay? But here's where things get interesting, because the building could be an apartment, could be a multi-story building, multi-apartment building, or it can be a single house, right? So you do need to know if this is multi-address, okay? I'm just going to put multi-address. If there are multiple addresses here, and that's going to be a boolean, okay? So, okay, I got my primary key as latitude and longitude. In that latitude and longitude will definitely be very helpful if I'm telling my shipper or if I'm doing the shipping, that hey, here's the latitude and longitude of this address. Okay, but it's also possible that that is multiple addresses, and therefore you will have an apartment number sometimes, and sometimes you may not have an apartment number. Okay, now this looks good, and so all I need to do is in the shipping address, instead of putting all those details, I can just put one of the primary keys. I can either put latitude, longitude, or the location code. But the problem is that when I put this location address just primarily based on latitude and longitude, um, my stuff won't work, right? So sometimes it's an apartment, sometimes it's a location address. So how do we deal with this situation, right? So that is where I think having a location code that is associated. So this is the primary key now in this table, the location table. That is the primary key. You have an apartment number, right? Sometimes the apartment number can be null, right? It can be null. But then it also has the latitude, which is a number, and the longitude, which is also a number, and they are foreign keys. They both are foreign keys. That if I have the latitude and longitude, I know I can get the location address. But this location code is there, it exists because sometimes there is only one location code, right, for one location address. And sometimes you may have more than that, right? So it looks like there is a relationship that is here, which is again a one-to-many relationship, right? Now, when you do this one-to-many relationship, right? So if you see that there is a one-to-many relationship, there is also, see if you see, so here it's a plane triangle, right? Instead of a plane triangle, if I do this, it says, hey, it can be one-to-one, and there's a bar there, right? It can be one-to-one, and in some cases, it can be one-to-many. So always there's a location code, right, for a location address. And sometimes it's one-to-one, sometimes it's one-to-many. So you make that relationship there. So now life becomes very easy for us, because now when it comes to shipping address, I can say, okay, so this customer is going to save shipping address associated with the first name and the last name, and it has a shipping sequence number. But all I got to provide is a location code, okay, which is a number, and that is a foreign key. And if I give the location code, I know that I don't need any of the address information, because I have a way to go and find them out based on, I can go to the location code, I can see what is the apartment number if it is there, then I can go to the latitude and longitude, I can find the building number, street name, city, state, zip code, everything, right? Oh man, I want to delete just that field. Okay, and I still have the customer ID because it's associated with the customer, right? Oh, okay, let it be like that. It doesn't matter, right? And they have a shipping address, right? And here again, we can say that a customer can have should have at least one address, right? but then also they can have multiple, right? Okay, they are having at least one address, but they could have multiple addresses, right? Okay, so we got the shipping address figured out. Now what happens is that, hey, so I have this customer, right? So this customer, um, to that customer, so there is a customer and he has a shipping address sequence number that tells that, hey, for this customer, I did send the stuff, I did ship it to a particular location that the customer told me to ship it. But I need to know the shipping address. I don't care about what was the customer shipping address sequence number that he or she has saved. I really need to know what is the actual address where I delivered it. So now what happens is I'm changing the shipping address sequence number into location code, right? And so I do have a relationship, not with the shipping, with the customer, I have a relationship that is a customer ID relationship, right? But really speaking, I also have a direct relationship to location because that's where I ship this order. And given that this is one order, I have a one-to-one relationship with the location, okay? And the shipping address that is here, let me re-relate that because it's causing more problems, okay? So the shipping address is also related to the location, right? And for a given customer ID, for a given first name, last name, there can be only one location unless otherwise I'm tracking multiple locations, right? So I'm just going to change this relationship to one-to-one. Okay, I change that relationship to one-to-one. And obviously between the customer and the shipping address, customer can have multiple shipping addresses, but they kind of need to have at least one shipping address. That's that. Okay. Wow. So you see how this relationship looks now, right? See, we started with a simple problem of an order for a customer. We didn't even go to product and product line items and order items and things like that. We were trying to model just the order and the customer and the shipping address and their location and how that could be related to a particular order, right? And here's the deal. I've explained to you what is first normal form, second normal form, third normal form, okay? In the Boy's Code normal form, they will say that a transitive dependencies have to have unique attributes, right? And in the fifth normal form and the sixth normal form, it talks more about the functional attribute of a particular table, right? So I'll give an example, okay? So let's say that I delete the customer, right? If I delete the customer, who all needs to get deleted? The customer needs to get deleted. The orders related to the customer needs to get deleted. And the shipping address that's related to the order needs to get deleted. You should not be deleting the location. You should not be deleting the location address. Those two remain, right? It's always there. Same thing, if I'm deleting an order, the order object gets deleted, but you should not be deleting location. And you should not be deleting the customer, right? So there is something called as insertion anomaly, deletion anomaly, and update anomaly, right? What does that mean is that when I update the customer, I should not change the order. I don't have to change the shipping address, unless otherwise I'm changing the customer's shipping address. I'm adding a new address or deleting a new address, right? Uh, the address information, the latitude, longitude, and the address information, and the location information, you might have to use some kind of geolocation software to pull that information. But once that is created, that becomes an independent record that can stay in your database. Nobody have to delete it, right? Same thing when I'm inserting a new customer, I insert a new customer. If I insert a new order, then I do need to know the shipping information, right? But the location address and the location codes, they don't have to change. So that's what normalization, table normalization, database normalization means, right? But the point I want to make it very clear is, you may be an expert in relational calculus. You know your set theory and set algebra and set calculus, and you've studied, did a lot of database research. If you don't know the business domain, how the business operates and how the business works, you cannot build a good database structure. Now, the other thing is, there are other companies, not as complicated as Amazon or Google, but a simple company. They may think that this whole address, latitude, longitude kind of organization is very expensive for them. Because for every address, they need to find the latitude and longitude. They need to get some geolocating software. They may say that, hey, I don't care about all those things. It's okay to have duplicate, because having some duplicate data in my cheap MySQL database is much cheaper than buying a geolocating software. In that case, you need to make a compromise, right? So what I'm trying to say is that, yes, go and understand relational calculus, go and understand set theory. I don't even know people even study those things nowadays, right? In my days, there used to be a huge book called Database Systems that has nothing to do with Oracle or DB2 or any relational database. It's purely about how you organize data using C pointers in a database. And they will talk about caching and everything, right? And it's very hard class to attend. And in my case, I didn't even attend computer science class, so I'll have to read it, right, and understand it. That's all great. But my point really is that, well, even if you know all that academic theory, you'll have to come back to understand the business context, and whether it makes sense to have some kind of academically pure database structure, or can you make compromises. This depends on many things, including what the company can afford, how much time you have to build something. Do you have some kind of special algorithm? There's an ETL algorithm where things have to work fast, and therefore you cannot, doing a join of all these tables is going to cause some performance issues. All of those things matter when you build your database. But the bottom line is that, yeah, so that's a good entity relationship structure. Right now, I really wanted to add more product line items and stuff like that, but I've just given you an idea of how to do data modeling. Now that I've done this data modeling, now I think it's very easy for me to go and build a real database, right? And maybe some Excel tables. So I'll put some of this information in Excel, some of that information in a real database, and connect with them and show you how to build a BI dashboard, right? That'll be really interesting, especially, one dashboard I'm thinking about already is that for my company, I need to know, hey, where do I ship? Where all do I ship? And how often do I ship to a particular location? Like, let's say that I'm always shipping to Washington, D.C. a lot, but I'm shipping very little items to New York, and I'm a company like Amazon. Guess what kind of business decision I can take? I can say that, hey, I need to have a local warehouse in Washington, D.C. But in New York, I'm not going to have a local warehouse because there's a lot of shipping that's happening in Washington, D.C. If I have a local warehouse, in Washington, D.C., then I'm going to reduce my shipping cost. You see, beautiful business decision you can take based on that, right? So I want to show you all that thing, how to put it in the BI dashboard and make it really realistic, right, with multiple data. And then there's also some statistical things that you can do in BI that also will come in the subsequent classes. But for now, this itself is a long class, and so you got to patiently look at this, learn from it. If you have any questions, again, obviously you can put that in the comments and I'll try to answer that. Thank you very much and see you in the next class.